doing transformation of graphs. So the first transformation is vertical translation or vertical shifts. So if I have a value c that's added to my function or a value c that's subtracted to my function, the effect of that is a vertical shift up or down. So to show that to you, let's begin with a quadratic function. So if you recall, the quadratic function has points 0, 0, 1, 1, negative 1, 1, positive 2, 4, and negative 2, 4. So all these points will be shifted up because we added positive 2 to your x squared. So I have to graph the transformation by adding 2. My 0, 1 will now be 0, positive 2. So it adds 2 points to all your y values. 1 will be up 3. Now my 2, which was supposed to be 4, is now a 2, 7. And then negative 1, 1 will now be at negative 1, 3. And that will be the new graph. So the plus 2 will shift it up. So this is a vertical shift or a vertical translation. So basically it moves up your graph up or down. The second one is on horizontal shift. So horizontal shift happens if you have a constant, a number that's added right onto your x value. So it's within the x value. So an example to that would be from your quadratic, you have an x plus 2 squared. So the 2 is within the x value. So it will have an effect of the x value, but the effect is always the opposite. So if something is added to your x, we always take the opposite of that value. So if I have an x plus 2 squared, the effect of that would be x minus 2. You're subtracting 2 to your x values. So let's have that with quadratic again. So let's do it with quadratic. So our first value in quadratic would be 0, 0. And then 1, 1. And then negative 1, 1. And each x value here will be shifted over to the left by 2 units. That's because we do the opposite. It will subtract the x values by 2. So if I have to graph the new graph, it's going to be now at 0. Instead of 0, 0, it's now going to be at negative 2, 0. Then your negative 1, 1 will now be at negative 3, 1. Then your 1, 1 will now be at negative 1, 1. And so all the points are shifted over by 2 units to the left. So the plus 2 there will shift or translate your graph 2 units to the left. Right? Now the next transformation is on reflection. So reflection is effective if you have a negative in front of your function or you have a negative in front of your x. So let's take first the reflection over the x-axis. So if I negate the y value, so y value that's positive, if you put in a negative in front of it, it will make the y value become negative. So there's a reflection over the x-axis. Again, let me use the quadratic function as my example. So quadratic function is 0, 0, 1, 1, negative 1, 1. And if I put a negative in front of my x squared, it will flip the graph upside down, which means that I am multiplying all my y values by negative. So my 0, 0 will still stay at 0, 0. But my 1, 1 will now become 1, negative 1. My negative 1, 1 will now be negative 1, 1, negative 1. And the graph will be flipped upside down. So this is reflection over the x-axis. This negative here would reflect your graph over the x-axis, or it will simply flip the graph upside down. That's reflection over the x-axis, negating your whole function. Now, another reflection is a negative in front of our x. So if you have a negative in front of the x, example to that would be y is equal to the greatest integer of negative x. Another example could be y is equal to the square root of negative x, like what we have in our example. So if I place a negative in front of my x, it will negate all my x values. So which means that if I had a positive x here, it's negated. We take the opposite of that. It's reflected over the y-axis. So this is reflection about the y-axis. So let's take, for example, here our square root. So if I use my radical function, my square root, I will have 0, 0, 1, 1. And then the square root of 4 is positive 2. So this is my parent function of square root. Now, if I place a negative in front of the x, this will reflect the graph about the y-axis. So the new graph will not be 0, 0. Then the x are negated. So instead of 1, 1, so this was 1 and 1, now it will be negative 1 and 1. So it will now be negative 1 and 1. And so is my 4 and 2, it will become negative 4, positive 2. So the graph is reflected about the y-axis. So that's the reflection over the y-axis. Now the next transformation is on vertical and horizontal stretches. So if I will multiply my function with c, a constant, so if it's multiplied outside of the whole function, it will reflect the graph. It will stretch the graph vertically. So this will have an effect on the graph, stretching the y values, multiplying the y value by the c. And if I will do it with the x, it will also affect the x values. So let's talk about first the vertical stretch. So here's a vertical stretch. So if I multiply it by a value that's greater than 1, so if my c is greater than 1, like say for example c is 2, say c is 3, and so on and so forth, it will multiply the y value by that number. So let's take a look at this example with the step function. So step function, let's review. The greatest integer of x is between negative 2 to 1, negative 1. The greatest integer value function is 2. Values from negative 1 to 0, the greatest integer is negative 1. Values from 0 to 1, the greatest integer is 0. So if I had to graph it, this would be our greatest integer function. All right. And so if I will multiply it by 2 times the value, the greatest integer, its effect will be on the y values. So the y values will be multiplied by 2. So the effect will be on the y values. So this is what the graph will look like. So let's go ahead and graph the new one. So instead of from x is negative 2 to negative 1 is negative 2, Now, x's from -2 to -1 will have -4. So the y value, -2, is multiplied by 2. So the x value from -1 to 0 will have -1, will now have -2. And then the y value of x value 0 to 1 will now still be at 0. And now the y value of x's from 1 to 2 will be at 2 to 4. From 1 to 2 will now be at 2 for y value. So you will see that your y values are multiplied by 2. There is a vertical stretch on your y values. So that's the effect of multiplying c outside greater than 1 outside of your function. Now, what about if we multiply the c to your x? So it's right in front of your x. Well, we always do the opposite. So we are going to multiply the x with the reciprocal of your value. So if you multiply it by 1/2, you're going to multiply it by 2. If you multiply this by 1/3, you will multiply the x value by 3. So it's always the opposite, which means that a value of c that's greater than 0, but lesser than 1, which are fractional form, the effect of that is a horizontal stretch instead, because it will multiply it by the reciprocal, which will become a whole number. So what I'm trying to tell you is, if we use it to our example here, we apply that to our example here. Let's do a greatest integer from -2 to -1 is supposed to be -2. From -1 to 0 will be -1. From 0 to 1 will be 0. From 1 to 2 will be 1. Now, if I multiply it by 1/2 to my x values, it will make it multiplying the x by 2 is the effect. So which means to say that my x will now be stretched horizontally. So there's a horizontal stretch on this. So instead of -2 to -1, now it's going to be from -4 to -2. And the y value will still be at -2. And then instead of -1 to 0, it's now going to be from -2 to 0. And then the y value is still -1. And instead of 0 to 1, it's now going to be from 0 to +2. And so on and so forth. So this will now be, so there is a horizontal stretch. So your x values are multiplied by c. Or in this case, in this particular example, it's multiplied by 2. So your x values are multiplied by 2. Now the next transformation is compression. So there is vertical and horizontal. So when do we have a vertical compression? If we multiply our function by a reciprocal. So a value that's greater than 0 but less than 1. So for example, if I have y equals 1/3 of x squared. So let's use that to our quadratic function. So let's do a quadratic function here. 0, 0 is the original function. 1, 1, and -1, 1. So this time our y values are cut into half. It's multiplied by 1/2. So the new graph will actually be 0, 0. Instead of 1 and 1, it's now going to be 1/2. So you see the effect? It's multiplied to the y value. -1 to 1/2 now. So from here, from the original value of -1, 1, now in the transformed value, it will be -1/2. So it's the y value that's multiplied by half. And so the new graph will now be this, which is more flat than the original graph. So it actually compresses the graph vertically. So it makes the graph more flat, which is effect is like stretching it horizontally, but it's really a vertical compression. Now, if we have a value that's multiplied to your x, and it's a whole number, so it's a c that's greater than 0, the effect of that is, of course, we do the opposite. As I said, you will multiply it by 1 over c. So your x values now are cut into half. So this is now horizontal compression. So there is a horizontal compression on this. All right, so let's see and do it with quadratic. So you have your 0, 0, 1, 1, negative 1 and 1. Now let me include 2 and 4, and then negative 2 and 4. So these are the points on the quadratic y equals x squared. If I transform and multiply it by 2, that means I'll multiply every x value by half. So my 0, 0 will still be 0, 0. So take a look at this. If I have my 0 and 0, I will multiply the x by half. So 0 multiplied by half will still be 0, 0. However, my 1 and 1, when I multiply it by half, I'm talking about the x, it becomes now 1/2 and 1. See the compression right here? So now my 2 and 4 will now be 1 and 4. So there is a horizontal compression. So if I graph, this will be instead of 1, 1, it's now going to be half 1. All right? It will be half and 1. And then my 2, 4 will now be 1 and 4. And then my negative 1, 1 will now be negative 1/2 and 1. And my negative 2 and 4 will now be negative 1 and 4. So your graph now is narrower and it is horizontally compressed. So these are the different transformation of graphs. So if we list them down, it would be, first is shifts, and that could be vertical or horizontal. The second one is reflection, and that would be over the y or the x-axis. And then there is, third one is stretch, and that's again vertical or horizontal stretch. And we have vertical or horizontal stretch. Stretch instead of vertical, sorry. So that should be stretch right there. And the last one is on the compression. So the last one is on compression. All right. Okay. So if all this transformation is done on a series of transformation of a graph, we have to follow our HSRV. So we do the horizontal shift, followed by stretches. So we do the shift, then we do stretches, then we do reflection, and then we do the vertical translation of up or down. So this is the order of transformation of graphs. So pay attention, order of transformation of graphs is in the order of HSRV. So order of transformation of graphs is horizontal shift, stretches, reflection, and vertical shift. Let me repeat, horizontal shift, so that's your movement left or right, stretch, vertical or horizontal stretches, reflection over Y or X axis, and then vertical shift up or